So, I mean, how many of you work with React, just off the bat? All right, that's good. How many of you use Immutable along with React? You should love this talk. Anyway, so a little bit about me. I am a CTO at Tarka Labs, but mostly I just write code, actually. And I'm kind of a polyglot. I like functional programming languages. Have dabbled a little bit with Elm and Haskell. I really love Clojure. And but in reality, I write a lot of JavaScript and Ruby and stuff like that. And of late, I've been doing mobile as well. We'll talk about that later. Mostly, this is meant to be an experience report. We built a pretty largish, React-based application. I don't view this thing as the right way to build it. It's just the way we built it and our experiences building it. And largely, we were inspired by Om and David Nolan's work on that. So how many of you know about Om here? Okay, few people. All right. So what Om is actually built on a language called ClojureScript. It's like a Lisp that compiles down to JavaScript. And the thing about ClojureScript is that it entirely is built on immutable data structures. So your vectors, your maps, they are all immutable. That means that if you make a change or if you add something to a list or a vector, you would actually get a new reference to a vector. And if you add something to a map, you would actually get a new map out of it. Now, you may think that, hey, there are just too many allocations, and if you have immutability, then you run into memory issues and stuff like that. Clojure and ClojureScript solves those problems with having a data structure called a bitmap vector trie, which actually intelligently shares a lot of the data between these structures. So I was really inspired by Om because it was actually built on top of React, and just because they used the immutable patterns on top of React, it ended up being faster than React out of the box for similar use cases. So we wanted to do these three things when we wanted to build this app. We wanted to embrace immutability because we knew, with our experience with Clojure, that it actually gave better results. We wanted to use pure components and components which had no side effects. That means that whenever we had to do a this.set state, we would question really hard and say, do we really need to do this.set state here and work just with props? And at the same time, we also wanted to have an eye on performance to make sure that the app responds well to user interfaces and all that. Although I do a lot of web development, I hate CSS. I don't think anybody here would say they like CSS a lot. It's just very inconsistent to work with. Wrapping your brain around CSS is a little hard. So the demo that I have built, it's going to look good, but only because I use Material UI. These guys are awesome, and they've built a very nice looking JavaScript thing for this. So, but let me quickly show you the app that I built. It's a simple Do Mvc app. Let me expand this a bit. All right. So it's pretty simple. You add a task. You set its due date. And then you say save, and you can add multiple tasks like that. And you can mark things as complete. You can go to the pending list and view only the pending stuff, and you can view the completed stuff. And it's an isomorphic app. The URLs change and all that shebang, right? Everything that you expect of a single page application to work, but a very minimal subset of it. This is the app that I'm going to demo, and like I said, it looks good only because I use Material UI. I absolutely hate CSS. But let's get back to this. Just a little bit of word about Virtual DOM and React. Actually, the thing that's more exciting about React is actually the Virtual DOM, right? When the React folks built it, they figured out that DOM operations were the slowest things that could happen on a browser. So they constructed an in-memory model of the DOM. And whenever you need to change things, they actually make another copy of the virtual DOM in memory and then try to find out the differences between the DOM object that's going to be versus the DOM object that's currently in, and only play those changes to the browser. And when you do that, you end up with better performance. Now, what this also means is that if you have a underlying state, and the state describes the UI, you could start considering your views as a function that turns your state into your UI. And that leads to thinking, okay, if views can be pure functions, what about the underlying data structure? Like people talk about React being the view in the model view controller. And before starting to use Immutable, people were asking me, okay, what's the model layer that you're using for React? And I usually say, I use arrays and lists and maps and the standard stuff that comes with JavaScript, right? I just use the normal objects. And Immutable actually falls in the same thing. I mean, it has a bunch of data structures that are pretty simple. Mostly you would end up using vectors and maps, maybe even sets a little bit, but that's about it. So what is Immutable? Like I said, if you create a map that's basically like object in JavaScript, you can set its key to a value. But then when you do that, you would actually get a different map, and you would not get the same map. So here, I create map 1, and then I set its key to value. And if I do, and assign it to another variable map 2, and if I do a triple equal to, by the way, always use a triple equal to when you're in JavaScript. I mean, there's no other way. So when you use a triple equal to, this will be false, right? So now I have another function. Immutable gives you a handy function called fromJS, because having to do set and .get and all these things gets a little difficult. So it gives a function called immutable.fromJS on this. So what this lets you do is it lets you give a JavaScript object, and it'll give you back an immutable structure. So let me show you that a little bit here. So let me go here. So for the sake of the demo, I have exposed the immutable object on this. So let me clear these stuff up. Map, this creates map object, and I could do map1.set. Description and some. And if I have to set the ID on it, again, so I'll have to call a change.set, because if I set it, if I create this map1 and I do that, I won't be able to get it. So I could do ID, and I can set this value to 2. Right? Now, this would give me a map object. As you see here, it's really weird. It has 2 entries. Like it has an ID and a description. So this is how the map is stored internally, but that's not very important. So what I wanted to show was that I could also do table.fromJS and actually do ID2 and description as some of the description. Right? Now, this can create the same sort of immutable map, which can have that. Now, going back to our slides. So let's consider we are building a to-do app, and we have a data structure which looks a bit like this. So you have a list of items, and each one of these items has this ID and some description and some tags that are there that people store. And you're creating a list of things and just pushing stuff into the list, right? And this is the data model that we're going to work with for our UI. So I'm just going to paste this into our app. Oops. So this is the first time I'm copying and pasting from a slide. Hope this works. Let's do that. So this is our UI. Let me reduce this a bit. And I'm going to create this list that's there. Okay, IFJS is not defined, so let me do that. So it's just IFJS is immutable.fromJS. I was just lazy to type it, and I needed the code to fit in a slide, so I just did that. Right. So now I have to-dos. So to-dos are a list and all that. Now that we have these patterns, we have the basic immutable list working and so on and so forth. I'm going to talk a little bit about instruct and cursors. Okay. Now imagine, Arya Stark is like going on her way back to the north, and she meets the Hound. I don't know if she meets the Hound. I don't know if she knows he's dead. I don't know. How many Game of Thrones fans here? All right, nice. So assuming Arya Stark's list, she says, okay, Hound is dead, I'm done with it. But Hound, guess what? Hound is not done yet. So if he goes and she needs to change that done there to false, right? Now that's going to be a painful operation because at that level, you have that last item in the list. If you change that, you would actually get a new map. And if you have to change that, the immutable list has to change. And if that has to change, the whole thing has to change, right? I mean, as you see, because we are using immutable, anytime you change things, so even if you change a reference in one of those lists, the whole list has to change, right? So that's where cursors come in. Now, what cursor allows you to do is that it lets you get to that bit, right? Now, so you could say, okay, my cursor is actually on the list, and that's going to go to position number 6. That's where this thing is, and I'm going to look at the done value in that, and I'm going to update that alone. And Imstruct is actually another open source library that I'm using, which actually provides this structure. So this library was written to support Omniscient, which is another JavaScript-based implementation for Om, but we ended up not using it because we actually had a few impure components, and we wanted to mix both pure and impure components in the beginning. And but finally we are pure now, but we'll get to that, right? So before doing that, let me do one thing. So I want to turn this to-dos list into a map where I want to access it by key. So I want to set the ID and then the value. So I'm going to do that. So I'm going to reduce this code, reduce the list, and so that it give me a map. Now, the way reduce works is, I'm sure many of you work with Lodash or underscore, and reduce does the same thing. So it actually takes a initialization value, then passes it through a function, and then keeps accumulating the value of the function, and then gives you the result back. So this piece of code actually turns our immutable list into a map. So let me do that. So I turn the immutable list into a map here, and then what I'm going to do is the whole state of my application is actually backed by an immutable structure. So I can actually create a cursor on that and update the cursor. So before that, let me talk about what the current state looks like. So here we have our app. Our app is actually running on a path called /tasks, and then it's actually on the tasks URL with these two tasks in it right now. So let's inspect the app state. Let's see what it looks like. So on the structure, I ask for a cursor, and if I don't pass in anything, it's going to get me the whole thing. And on any immutable object, I can do a deref on it. And this will give me the, once I have a cursor, if I do a deref, it will give me the underlying immutable structure. And I can then do a 2JS to actually write it into JavaScript. So I'm going to clear this. I'm going to run this. And as you can see, this is the state object. It has this path, which is the URL that it has. And then it has a bunch of tasks that I created, actually. Right? Pretty simple, straightforward. This is the current state of my application, right? And then I also have tasks now, okay, which follows a similar thing. So it is a map, just like how this tasks is a map of ID and value. So I'm going to do a tasks.2js, right? And that's what it looks like, right? So instead of ID being these fancy numbers, I have these IDs as 1, 2, 3, 4, all the way to 7. And then this has the object that's here. So what I'm going to do is I'm going to get this app state. I'm going to get a cursor to the tasks value, okay? Sorry, it's just a bunch of stuff. Right, and then I'm going to update it. And I'm going to simply set this to tasks, right? So I mean, this is just ES6 syntax. Now Chrome supports the entire ES6 thing, so V8 completely supports it. So you can actually just start writing inline functions like these in the Chrome console, which is actually nice. Now, if you look at the thing here, so we have like 2 statements. So I'm going to change this, and I'm going to set this to tasks, and boom, I have this entire list. Now, the UI entirely is like, is a function of the underlying state. So if I set the state object instead of having to do this, it actually automatically re-renders this whole thing, right? And we'll talk about code a little sooner. A little later. So I have to say, Arya goes in and now she meets the hound, and now she wants to change this to not done, right? So, and also because, he's kind of become a little nicer and so on and so forth. So I'm going to go to tasks. The ID is 7 on this, and I'm going to update this to false. Update the done flag of this to false. Right. Now, that's it. So the done flag actually becomes false right there. Now, so this is extremely powerful because you don't have to write a bunch of actions and then try to reduce the state and so on and so forth. Or use the Flux architecture and try to figure out and then emit events and subscribe to events and all that. Now we don't have to do any of that. So here we have like a global state. We are just manipulating the state, and we basically re-render the entire user interface every time the state changes. This is like 1990s web development all over again, right? Where you just render the entire server state and you don't have to bother about, okay, what the current state, all these event handlers and all the, all the callbacks and all that kind of stuff. So this becomes very simple. So how do we achieve this? So I'm going to jump a little bit into code, and then I'm going to talk a little bit about this. I hope the code is visible from there. Right. So I'm also a huge Vim guy. Even on Xcode I use Xvim, IDEA I use IDEA Vim. I'm like huge Vim guy. Anyway, so here this is the task list that we have. Here we are basically going through the list and we are showing a list of task items. I have this decorator. I have a higher order component called component here, right? What this allows you to do is that it takes a base component and then it maps it on to say which state I'm going to look at. Now this is pretty nice because now I can have a deeply nested component tree, and you could have like task and a task item that could have like child components and so on and so forth. Now, what this allows me to do is it lets me subscribe to changes in part of this component tree. So if I don't have to do, if nothing changes in the tree, I have a should component update that's implemented in the component, which simply doesn't render the component, actually. It doesn't even go through the render method where it has to generate the, virtual DOM tree and so on and so forth. It simply skips over the whole thing so that it would do that. So let me show you the component method. And this is possible because, it's syntactic. So I use a different, all right. So here, what this provides is like a higher order component. If you notice here, when you call this method, it actually creates a React class within that. And it by default implements a should component method. And the should component method does all this checking, right? So as long as it has these props, it'll simply check for the value of these props and says, hey, you know what? All these props are valid and nothing has changed, so go on. But if you pass it a cursor, it'll actually deref into the immutable structure, and it'll actually simply do a reference equality check of these immutable structures and say, hey, nothing has changed on the immutable structure, and so on and so forth. And it also has a few nice things for finding out computed properties. Like, for example, if you want to have a property that's based on a route and you want to check those things in, so those, it has a little bit of work where it can figure out, okay, it builds a graph of these things and say, okay, this is like a computed property, it depends on this previous property, so I'll have to resolve that first before I do all these things. I have I've checked this component into GitHub. I'll share the link for the GitHub project as well, and I'll upload the slides. So what this then does is that it actually, since it's a higher order component, finally it just renders the lower level component and just figures out whatever props it has, and then it also passes in the other properties that you pass on to this and to this higher order component, and then it renders the actual component beneath the scenes. We definitely need a better vocabulary to talk about React and components. So then it's the should update method. The should update method also is heavily inspired from Omniscient, although we made a slight bit of changes to this. So let me, right. So all this does is that it tries to figure out if it is a immutable property, or if it's an equal state, or if it's an equal props, and all those kind of things. And finally, and I mean, it makes certain allowances for using non-default props. So it actually, I mean, if you are using state, it's fine. It would still work with state as well. Now, it is slightly different from the pure render mixin. Pure render mixin only does these shallow comparisons, although pure render mixin should also work. But we were dealing with cursors, and sometimes we just passed in cursors without dereffing them, so the pure render mixin won't work in those cases. So what we decided was to implement our own should component update on that. I'm sorry if it's too much into React, but it's pretty much what's built on. So I want to show one more cool thing on this. So say, for example, you had this, you have these tasks, and then you have a look at pending, and then you have all this stuff, and then you have completed, right? So what I'm going to do is I'm going to change the state here. So I'm going to dump the state first. I'm going to say, bring this here. I'll say I'm going to say JSON dot stringify app state dot search. I'm going to take the entire thing to JS on this. Okay. Now I have a serialized state actually, right? So I have this bunch of things that are there, and imagine you are debugging a project and so on and so forth, and you want to like tell hey, you know what, I'm running into this issue when I have this, right? And you want to reproduce it. Generally, it's hard. So what you do is I'm going to copy this whole state. I'm going to open another instance of the app actually, and I'm going to go back to the same. I'm going to create another mode here. So what I'm going to do is like I'm going to say our old state equals parse, and I'm just going to paste the whole thing here, right? It's just a state that I have taken from say one instance of the app to the other instance of the app. I have the old state here, so I could do the same thing. Right. And here I'm just going to say old state. So remember, this is like a new instance of the app and all that. So when I do that, I think there's some network issue. I think JavaScript didn't get loaded. Let's do that one more time. Right? And when you do that, it actually goes to the URL, it does this, and then shows the pending stuff. So it makes debugging really simple. I mean, like even if across, I mean, like if especially on a team, and then say, hey, I'm running into this issue, can you have a look at that? And then instead of doing screen sharing and all that, say, hey, this is my state, and this is the app I'm working on. Just go figure this out, right? And it's so much simpler, actually. So, I mean, think about all the error reports and all that you could get. With a little bit of sanitization for security and all that, you can actually pretty much get to the right right place in the app, without losing much time. And what else? And this is all brilliant. This is all very nice. But there are some challenges we faced. Let me quickly show you the app that we built, actually, and some of the challenges we faced on that. So, okay. So this is the app that we built. I mean, it's okay if it's not visible from the far, because I'm just going to walk through a little bit. So as you can see, it is a pretty, fully featured app. Wi-Fi is pretty slow. So you can actually view trips here. And I mean, these are all custom overlays. And some of them are custom overlays. Some of them are just markers that are in there. And if a person is driving on the main map, you would actually see him drive. I mean, actually do the whole thing. And it's not just for one person. I mean, like if you have like 25 or 100 people on your map, you would actually see all of them moving around. I mean, it's in the night. So pretty much all of them have their cars parked, and so on and so forth, so you don't see them drive, but you do this. And this app, the entire state is stored in this tree, so this is actually very similar to what we had. So let me show you. So this is a dev instance, that's why we have the app state exposed. Usually it's not a good idea to have your app state exposed to the entire world. Right, so I do Tool.js. So if you notice, the state object becomes pretty gnarly after a time, right? I mean, so you have everything from drivers, and this one guy, and this guy has all this stuff, and you would find that this guy has his trips that are there, and that's, I mean, like, if you see, this whole thing becomes gnarly, right? So one of the challenges we faced when we are building this is among developers, we had to like agree saying that, okay, this is the structure we are going to follow for the state. And say, for example, a driver module is there, and your driver view needs these details. But then a driver detail view would need more details, right? And both of these views should agree that, okay, I'm going to use the same kind of structure, and it's almost like a global structure. And whenever you change things, you have to make sure that the other components are also taken into account. So which makes it a little brittle. It's just it has a lot of conveniences, but I guess it's the trade-off, right? When you use a deeply nested structure like this, and then you're sharing the structure and so on and so forth, it's a problem. Om Next, which is what David Nolan has been working on, has gone completely the other direction, because now they have an interface called iQuery, and it's very similar to what Falcor is doing with AngularJS, actually. So our Facebook is doing with Relay. So some of those kind of things would actually help this deep nested global immutable object problem. One other challenge that we faced was, sometimes, like for example, Google Maps, they don't like immutable. Internally it manages a lot of things, but it doesn't work very well with the Immutable API, right? I mean, when say for example we have this overlay marker, which is a component which you saw in the main guy, and if that overlay marker needs to be driving around, that becomes a problem. So we had to cordon off certain areas of the application, especially Google Maps and all that, and use different reactive patterns and not use this pattern. So there we just use RxJS to find out as and when we get events from PubNub. For these changes, we actually update the positions directly using the Google Maps API, after the component had mounted, and not rely on redrawing the component. So those are the only challenges, but apart from that, testing becomes a breeze with this, because almost all your components are pure components. You don't have any state changes, so and all these are immutable objects. So testing as such, I felt became simpler rather than getting more complicated, and the development time, of course, crashed. I mean, we couldn't have, this project took about, it was 4 people and like 4 to 5 months of effort. We got pretty much 80% of that, the app that you saw working. So productivity-wise, it was amazing to have this sort of a, just change the change the global immutable structure and everything changes without having to worry about emitting events and subscribing to it and so on and so forth. And I mean, we started evaluating Redux after we went this route. I think Redux actually is pretty nice because I worked with Elm and I've looked at the startup template, and Redux more or less follows the startup template. I'm sure someone would grab me after lunch and say, hey, that's not what it is. But I mean, at least to my views, that's what it looked like. And it's awesome, right? I mean, for people who are starting out now, I mean, I would definitely recommend checking out Redux as well. And that's it. I don't want to keep people from lunch, but I would be happy to take questions.
We can have questions now.
Just a quick one. I hope you know about LM-Lang.
Yeah.
Yeah. So in comparison to ClojureScript, I think it is fairly good enough to for a Clojure programmer to go for a ClojureScript for building these, immutable JS and ClojureScript with React. But do you think ELM-Lang would be much better choice for people who are just coming into the functional programming, just to try their hands?
Well, Elm, I really like Elm. But so Elm has this thing. I mean, it's not just about the language, right? I mean, it also has this certain static signal graph that you get along with that, right? So you need to have your inboxes and the messages and all those kind of things. So it is also that paradigm that you have to get used to. And it's also that type system, right? Type system of Elm is a little more rigorous than the type system, or if you can call what JavaScript has as a type system, right? So it's very different, actually. But actually, just a fun fact, I had been trying to do Haskell for a while. I kind of gave up, but then Elm got me back to Haskell, actually, after I started working with Elm. I mean, and it was very nice because I never once saw undefined is not a function in the console, which made my life, it filled me with warm glow inside when I was writing Elm code. But definitely would recommend both these languages, ClojureScript and Elm, but they take very different views of programming. Like ClojureScript is all about data as your underlying structure. I mean, once you got your data right, everything else kind of follows. Elm, on the other hand, is very rigorous when it kinds of how do you define state and how do you have functions shepherd state from one point to the other.
All right. Thank you.